I'm going to review allosteric controls over enzymatic activity. So I'm going to draw a circle that represents an enzyme. And enzymes are large protein molecules that have an active site. And the active site is where the substrate will bind to an enzyme. One of the controls over enzymatic activity are called allosteric controls. I'm going to talk about two types of allosteric controls: allosteric activation and allosteric inhibition. I'm going to start with the case of allosteric activation. There is another site on enzymes that is called the allosteric site, which is where an allosteric activator or inhibitor will bind with the enzyme. In the case of an allosteric activator, will plug into the allosteric site on the enzyme. If the allosteric activator is not plugged into the allosteric site, then the active site of the enzyme will not be the right size to receive the substrate, and the reaction will not occur. On the other hand, when the allosteric activator plugs into the allosteric site, that changes the shape of the active site on the enzyme so that it is the proper shape to receive the substrate, and the reaction can go forward. The opposite of an allosteric activator is an allosteric inhibitor. In the case of allosteric inhibition, you have an allosteric inhibitor. And if the allosteric inhibitor is not plugged into the allosteric site, then the active site of the enzyme will be the right shape to receive the substrate, and the reaction can continue forward. If the allosteric inhibitor is plugged into the allosteric site, then that changes the shape of the active site on the enzyme to the wrong shape to receive the substrate, and the reaction will not move forward. If the allosteric inhibitor is unplugged from the allosteric site, then the active site of the enzyme will be the right shape to receive the substrate.